There are 8 billion versions of the truth walking the planet right now. 8 billion unique lives, 8 billion conflicting opinions on everything from geopolitical borders to whether pineapple belongs on a pizza. Every single year, governments, massive NGOs, and global corporations spend trillions of dollars trying to move those dots. They want to reduce poverty in a rural province, launch a new tech product, or stop a virus in its tracks. But here is the terrifying secret. Most of the time, they are just guessing. We try to measure the vastness of the ocean by staring at a single cup of water. We try to understand the heartbeat of a nation by talking to a few thousand people who happen to answer their phones on a Tuesday. We call it data, but without a specific kind of logic, it is really just a high-tech hallucination. Our human brains are built to find stories, not statistics. We see a neighbor lose their job, and we think the economy is collapsing. We see a green field, and we assume the harvest is plenty. We are naturally terrible at seeing the big picture, because the big picture is simply too big to fit inside a human skull. Think of the world as a massive, jagged mountain range. It is messy, it is shifting, and it is covered in fog. If you are a leader, a student, or a researcher, you need a map. But as the old saying goes, the map is not the territory. If your map was actually as big as the mountain range itself, it would be useless. You would be walking on a piece of paper the size of a continent. To navigate, you have to simplify. You have to shrink 8 billion data points into a single, clean average. But in that shrinking process, something dangerous happens. If you do not know the math of how that average was built, you aren't holding a map. You are holding a blindfold. By the end of this video, that is going to change. I am going to show you the spoonful of soup theory that runs the global economy. We are going to watch chaos turn into perfect order using nothing but code and logic. And once we are done, you will have a new superpower. You won't just see a news headline or a 9 out of 10 statistic and nod your head. You will look closer and ask, which dots did you pick, and why were you so afraid to show me the others? The ghost in the machine. To understand why our data fails us, we have to look at the ghosts, the people who aren't there. During World War II, the military looked at bombers returning from missions riddled with bullet holes. The holes were concentrated on the wings and the tail. The natural, common sense reaction was to add heavy armor to the wings and the tail to protect the planes. But a mathematician named Abraham Wald saw a ghost. He realized they were only looking at the survivors. The planes that were hit in the engine or the cockpit never made it back to be counted. They were at the bottom of the ocean. By armoring the holes they could see, they were ignoring the fatal wounds they couldn't see. This is survivorship bias, and it is the ghost that haunts almost every study you have ever read. When we only listen to the voices that returned from the mission, we make disastrously wrong decisions. In the modern world, this ghost lives inside our echo chambers. Think about the last time you saw a political poll or a market survey. If you conduct a study via an app, you are only talking to people who own smartphones. If you conduct a survey in a city square, you are ignoring the rural farmers who are the backbone of the economy. We end up talking to the people who want to be talked to, the loud, the reachable, and the angry. This creates a massive selection bias. Mathematically, this looks like a bell curve that has been smashed to one side. In a perfect world, our data should sit in a beautiful symmetrical arch where the average is right in the middle. But because of these ghosts, the curve skews. It leans. It lies. When an economist or a project manager looks at a skewed curve and mistakes it for the truth, they end up building schools where there are no children or sending seeds to a desert. They are optimizing for a world that doesn't exist, all because they forgot to account for the silent majority that never made it into the spreadsheet. To find the truth, we don't just need more data. We need to learn how to hear the silence. The art of the sample. Imagine you've spent all afternoon cooking a massive pot of soup. You want to know if it needs more salt. Do you have to eat the entire 10-gallon pot to find out? Of course not. That would be insane, and you'd be too full to eat dinner. Instead, you take a single spoonful. If you stirred that pot well, That one spoonful tells you everything you need to know about the thousands of spoonfuls remaining. This is the spoonful of soup theory, and it is the heartbeat of modern science. A representative sample isn't just a shortcut, it is a mathematical mirror that reflects a giant reality in a tiny space. But here is the catch. You have to stir the pot. In the real world, the ingredients don't always mix themselves. This is where stratified logic comes in. Imagine a city where half the people live in skyscrapers and the other half live in quiet suburbs. If you only dip your spoon into the skyscraper side of the pot, your data will taste like steel and glass, completely missing the trees and lawns of the suburbs. To fix this, we divide our world into strata, neat, colorful layers based on things like age, income, or geography. We make sure our spoon touches every layer in the exact right proportion. We aren't just guessing anymore. We are engineering a perfect reflection of a messy world. This brings us to the randomness paradox. If I asked you to pick 20 random people from a crowd, your brain would accidentally look for interesting people, or people who look friendly, or people standing right in front of you. Humans are actually incapable of being truly random. We are patterns-seeking machines. But for a computer, true randomness is a basic language. By letting the code pick the dots, we strip away our human biases and let the raw, unpolished truth speak for itself. The calculus of close enough. There is a beautiful moment in data science called the law of large numbers. Imagine you are flipping a coin. If you flip it 3 times, you might get 3 heads in a row. You'd think the world is broken. But if you flip it 1,000 times, the chaos begins to vanish. A jagged, unpredictable line slowly settles into a perfect, flat, predictable horizon at exactly 50%. This is the aha moment. It is the proof that underneath the surface of our chaotic lives, there is a rigid skeletal structure of logic that never moves. However, even with the best math, we are rarely 100% sure. This is why we have the margin of error. Think of it as a shadow of doubt that follows every statistic. When you see a poll that says a candidate has 45% of the vote with a plus or minus 3% margin, that isn't just a boring footnote. It is a geometric boundary. It is the math admitting that the truth is a small neighborhood, not a single point. If the shadow of doubt for 2 different candidates overlaps, the math is telling you it's too close to call. Understanding the margin of error is the difference between being a victim of a headline and being a master of the data. Finally, let's bust the sample size myth. People often ask, how can a survey of only 1,000 people represent a nation of 300 million? It feels wrong, doesn't it? But here is the secret of diminishing returns. Once your soup is stirred, the size of the pot doesn't actually matter. Whether you are tasting a cup of soup or a swimming pool of soup, one good spoonful gives you the flavor. Mathematically, once you reach a certain sample size, usually around 1,000 to 1,500 people, adding more people barely changes the result. You don't need a million voices to hear the truth. You just need to make sure the voices you do have are the right ones. Field notes from the real world. In my 9 years working in rural development across the globe, I've learned that a mathematical model is only as strong as the person holding the clipboard in a dusty village. When you are standing in a field trying to measure agricultural development, those abstract dots on the screen become real families, real crops, and real stakes. You quickly realize that the perfect random sample you generated in the lab might be blocked by a flooded river or a broken-down truck. This is where accountability becomes more than just a corporate buzzword. In the world of meal, monitoring, evaluation, accountability, and learning, the most important letter is actually the last one: learning. Measuring a failure is useless if you don't have the humility to learn why it happened. It's about creating a feedback loop where the data doesn't just sit in a silent spreadsheet, but actually talks back to the people in charge. If the seeds didn't grow, the data should tell us why. Was it the soil, the timing, or the training? To find the truth of impact, we use a logical tool called the counterfactual. It sounds complicated, but it's essentially the ultimate what-if question. To prove a project actually worked, we don't just look at the people we helped. We have to look at a similar group of people we didn't help and compare the two. This is the control group. By measuring the gap between what happened and what would have happened anyway, we find the true signal of progress. We aren't just counting successes, we are isolating the exact moment where human effort changed the course of a life. Engineering a better future. We live in an era where we are drowning in data, but starving for the truth. The bridge between collecting numbers and finding insight is currently a bottleneck of manual reporting and human error. At Ignex, we are building the tools to automate this truth-finding process, using code to strip away the noise so that decision-makers can see the world as it actually is, not just how they hope it to be. We believe that when you combine the rigor of engineering with the empathy of rural development, you get something powerful. You get a map that actually leads somewhere. But this is just the beginning of our journey into the logic of the world. In our next lab experiment, we are going to step away from populations and look at individuals. We're diving into the high-stakes world of game theory, the math of strategy, conflict, and cooperation. We'll see why rational people make irrational choices and how winning is often a matter of understanding the hidden rules of the game. If you're ready to see the invisible lines that connect us all, join the lab by subscribing. I'm Wisner, and this is Ignex Dev Lab. Let's keep engineering a better future, one data point at a time.